This video is going to talk about some steps to success and basic ideas and how to set up a tree diagram and build probability models when you are maybe doing a simulation or running an experiment. So a tree diagram basically is just this flow chart that shows us everything that could occur when we are doing our little experiment or simulation. So in this case, we're going to be taking a look at a problem where we are flipping a coin twice. Okay, we're going to flip a coin twice, and we know that the first time we flip the coin, what could happen is we could get heads or tails. So our first step here is we need to draw a tree diagram, and that is already on the screen for you. But here I am, right here. I am getting ready to flip a coin the first time, and there are two outcomes that could happen. I could get heads, and if I get heads, I'm going to travel down this path right here. If I get tails, I'll travel down this path. So these paths are basically showing me, here's what could happen when you flip the coin. Right? So we draw the tree diagram, which says the first time maybe I get heads, and then when I go to flip the coin again, I could get heads or tails the second time. So you can see in the tree diagram there's 4 different things that could occur. I could get heads, then heads. I could get heads, then tails. I could get tails and heads. Or I could get tails and then tails. Those are the things that could happen. So I've got my tree diagram all set and drawn. That's step 1. Step 2 is I need to label the probabilities on these. So when I'm standing here in the beginning, back to the beginning, and I'm going to flip a coin, I have basically a 50-50 chance that I'm going to get heads or tails. So I'm going to label probability along this path right here. The probability I get this path is going to be 1 out of 2. 1 head out of 2 outcomes. So I'm going to label all the probabilities, and in fact every time that I label, or every time that I flip a coin, there's a 50-50 chance. So all of these are going to have a half on them. And the key with tree diagrams is just to remember that when you want the probability at the very end, the probability that you finish somewhere on the tree diagram is that you should multiply the probabilities that you see as you travel. So we're going to calculate all the end probabilities, and that is going to be step 3. Step 3 says, hey, let's travel. What's the probability I get heads and then heads? Well, I'm going to have to multiply the half times the half, and a half times a half is 0.25, and every end on this tree diagram will be half times half, or 1/4, or 0.25. So step 3 is calculate the end probabilities. Step 4 is to build a probability model, and a probability model is a chart, a table that just lists all of the outcomes that could happen and what their probabilities are. So we already talked about this one has 4 outcomes that could occur. Heads, heads, and that's a 0.25 chance. Heads, tails, that's a 0.25 chance. So a probability model basically is this. It's just this table that says here's all the things that could happen in this story. You get heads, heads, probability is 0.25. Heads, tails, the probability is 0.25. Tails, then heads, 0.25. Tails and tails, 0.25. Now, we'll take a look at one more example here and do these things in order. We'll build a tree diagram. That's going to be our first step, draw a tree diagram. Then we'll label the probabilities. We'll calculate the ends, and we will construct a probability model. So in this case, we're going to look at being dealt 2 cards from a deck of cards. Now, when we're dealt cards, we are given a card, and then we are given a second card. We need to remember that the first card is not placed back in the deck. This is without replacement. So we're dealt 2 cards, and we're just going to analyze the color of the cards that we get to make this problem a little bit easier for now. So the first thing we need to do is draw a tree diagram. Okay, we need to realize the first card we get could be red, could be black. There's 2 choices here, and this is going to look a lot like the heads tails example. I could get red on the first card, or I could get black on the first card. Now, the probability that I get red is a half, because there are even number of reds and blacks, but I like to write 26 out of 52 when I deal with cards, just because I know there are 26 red cards out of 52 total cards. Now, when I do that, I have to remember once I get this red card, now there's 1 less red card in the deck. So when I go to find the probability that my second card is red, probability I traveled this path, there are now only 25 red cards left, and there are actually only 51 cards total in the deck. So I'm going to label these probabilities here. The probability my first card is red is 26 out of 52. 26 out of 52 cards are red. Now when the dealer is getting ready to give me my second card, there are only 25 red cards left, and there are only 51 cards in their hand to give me. So this probability is 25 reds out of 51 cards left. Okay. If I got red the first time, I have to remember there are still 26 black cards left in the deck, and there are 51 cards left in the deck. So 26 out of 51 chance I get black the second card. And really the bottom of this tree diagram is doing the same thing. That's step one. Label my probabilities. Think about those. It's a little bit harder than the coins. And after I do that, I need to calculate the end probabilities, which says multiply through, if I want to know red, red, it's 26 over 52 times 25 over 51. And I need to do that on every branch and multiply through. And in this case, we realize that our answers are not always equal. And when we're done with multiplying through, then our next step is to build a probability model, to list off what are all the outcomes and what are their probabilities. Okay, so the outcomes in this case are red, red. That probability is 0.245. It's this one right here. Another outcome is I get a red then a black. That probability is 0.255. That's this one right here. Another outcome is black then red. That probability is 0.255. That's this one here. That's black, red. And the probability that I get two blacks, black, black, is this one right here, 0.245. So that's the main idea behind building a tree diagram, labeling each individual probability, multiplying through to find the end probabilities, and then to create a probability model which shows everybody, here's everything that can happen, and here's the probability that